Hi everyone. We are here today to talk about observational analytics and how Synapse Data Explorer helps with that. My name is Uri Barash and I'm the Group Program Manager for Gusto and Azure Data Explorer, Synapse Data Explorer, and I'm here to share with you our journey with this technology. Telemetry is the fastest growing segment of data in the industry today. It's everywhere. We find it in IoT sensors, in application log, click streams, everywhere where human activity or machine activity needs to be recorded in order for us to understand how businesses, factories, buildings, organizations work. It's fairly straightforward to generate it. You instrument it on the sensor, on the activity, and it immediately gains huge amounts of data. We're talking about huge numbers, like 50 billion connected devices by the end of the decade, and 175 zettabytes of data by 25. It's huge. When we're looking at what it means, when we talk about telemetry data, we're talking about multiple aspects. First, it's machine generated either because it recorded human activity or machine activity. It very often is semi-structured, text, JSON, or time series, because it needs to be flexible to deal with the frequent changes of schema, applications, vendors, and versions. It comes in huge volume, in high velocity, and very often in very few large fact tables or data streams. So what makes observational analytics special? We are seeing high velocity of business environments, and we see it accelerating. We have information flowing in. We are expected to use it to constantly improve how we operate and be able to answer new questions as they come very, very quickly. The data itself keeps changing with new types and new versions of devices and applications, with new vendors and business partners that we work with, and the evolution of information that drives a deeper data collection. A lot is encoded in text or JSON that allows the data pipelines to stay fairly stable, but ETLs cannot keep up with the constant change to structure. This is why we typically ingest this data in the row and apply schema on read over it. We've trained our users to expect real-time access to data. And very recently, we've seen a large media events with millions of subscribers where the media company wanted to ensure that the subscribers are getting the right quality of video to their devices. They monitored every IP packet that carried video from broadcasting to consumption on the user's device and made routing decision in real time during the event in order to ensure that the right experience is delivered. Sometimes the analytic systems cost more than the optimization value that it can deliver. Therefore, reducing the cost of analytics unblocks new scenarios and new capabilities that were not feasible before. And the most interesting aspect is that with observational analytics, we are looking for the unpredictable phenomena. This is why observational analytics first bloomed in security, where hackers are always avoiding the detection mechanisms that are put in place, and operational monitoring, where malfunctions never happen when you expect them. And therefore, the ability to look for and detect new phenomena is the key element of observational analytics. Let me show you what do we mean by high velocity data. Here we're looking at a single table that holds the logs of the Azure Data Explorer, Synapse Data Explorer services. It has 1, 2, 3, 4 commas, which means 63 trillion rows. And when we're looking at how many rows are being ingested on a regularly, we see that about like 1.5, 1.6 billion rows are ingested per minute. This is a live table that our developers and program managers use regularly to understand how the service works. So, what is Gusto? Gusto is a complete analytics and storage engine that is built all the way up from compute and storage and is now available also in Azure Synapse Analytics. It's optimized for timestamp data, logs, time series telemetry. It has native support for free text, structured and semi-structured data and analytics. It provides low latency access to the data at scale. And exposes a human-friendly query language that enables more and more engineers, knowledge workers to run ad hoc analytics immediately as they need it. Let me show you a little bit more of the power of the technology. We're looking here at a relatively small table with only 1.2 billion records. It is all the activities that GitHub users executed between the dates of like 2016 and 2019. If we look at the data, we can see that the data is pretty complete. We are aggregating the count of operations per day between these dates, and we can see that people work less with GitHub during the weekends and even less during the holidays. If we look at the data itself, we can see that some of it is well structured, like the operation ID, the operation type, but a lot of it is completely open in JSON format. For example, who is doing the operation, what repo is it doing the operations against, and what is the payload. Every row can have its own schema and can have its own payload. With the Gusto technology, we can actually query inside the JSON field and create a computed column, for example, for the display login, which is the unique identifier for a user in GitHub. It also allows us to run a query like, how many unique users have we seen in GitHub during this period? And the answer is 16 million users have operated against GitHub between these dates. Now, this query took 3.4 seconds, and it practically opened up 1.2 billion JSON records and computed a unique users count. Let's take a look at additional example. In this data set, we have 30 terabytes of data. On disk, we keep everything compressed, so on disk it takes about 3 terabytes of data only. And the data is organized in two main tables. One is the trace table that has 22 terabytes of data, and the other one is a performance counter table. This is a log table, a broader table with multiple columns and diverse content, and the performance counters is really measurements, time series, or metrics. We'll start with the log table. The trace table will take the trace table, we'll pipe it into the count operator that takes a 41 billion row table and 15 columns and transform it into a 1 column, 1 row table with the number 41 billion in it. But let's do something that's a little bit more complex than counting rows. Let's take those 41 billion rows, slice only one day out of them, so we only get 800 million records, and then aggregate those 800 million records by the error level. And we can see here that we have 2.5 million errors in this data set. By the way, this query ran for 790 milliseconds. By the way, all the queries that I'm running here are completely calculated from scratch every time I run them. Nothing is cached. So before we drill down and see what is the reason for those 2.5 million errors in this data set, let's take a look at the data. In this data, we can see we have date and time, low cardinality strings, high cardinality strings, integer, doubles, and whatever you can expect from a database, all the way to full text fields. All of them, including arrays and JSON columns, get indexed automatically without the need of any tokenizers or any other elements as the data comes in. When we're looking at the role field, we can see that the role field is practically an aggregate of two different data points. One is the machine that's generating the traces, and the number is the index of the machine in the array. It doesn't help us to understand if there is one type of machines in this array that's generating more errors than the others. So what we'll do, we'll parse the role field into the role type element, throwing away everything after the underscore. And then we'll aggregate this by the role type in bins of 10 minutes and see how it behaves over time. As you can see, there is one type of machine, the SPI role machine, that's generating more errors than the others in this data set. By the way, this query runs for 400 milliseconds. This is the type of performance that column stores and deliver. But let's take a look at a query that other products have harder time with. Let's find the user that has suffered the most during that day by searching for login events, extracting the stable ID from the event text as we've seen earlier, associating the session ID with the stable ID, joining it back into the alerts table, and then aggregating by users to see which users got the most errors in this data set. And we can see that 3309 is the poor soul that suffered almost 2,000 different errors. We can now dive into what 3309 experienced and see by extracting the actual error code from the event text, we can see that in this case, both the database was not found, and there was some problem with the network for this specific account. And because the cardinality is pretty much the same, we can assume that this is the reason and that those two errors are connected. So we've seen how we can aggregate data really quickly on dimensions, which is a classical dashboard element. How we can investigate and get to the root cause, and we can even dive into a specific session and see what's happening before, during, and after the error. And we can also run alerts on the same data set. And this is what's unique in systems that build on Azure Data Explorer. The phenomena that you investigate from the dashboard and the phenomena that you investigate because you got an alert they all rely on the same data. So when you investigate something, the same data that generated the alert is there in the system to help you understand the answers. No gaps between those different systems. In the data domain, quite a lot of people are using the SQL query language. This is why we made it possible and easy to convert SQL statement into KQL, the language that is being used here, but also in Azure Monitor or Log Analytics and a bunch of other security products from Microsoft. Not only we can convert queries, but we actually can run SQL queries natively in Azure Data Explorer. So this is a T-SQL query that just executed as is. Practically, Azure Data Explorer also supports a TDS endpoint. So for all practical reasons, it can serve as a read-only SQL server, and we'll talk about it more in the architecture section. Let's switch gears and talk a little bit about time series. Now we're looking at the performance counters table. As I mentioned, it's 6.5 terabytes of data, hosts 30,000 different time series with 35 billion measurements in this table. And now we're looking for the 3 machines that reach the highest CPU in this data set. And we'll try to see why those machines reach 100% CPU, or at least were the highest ones in the array. And when we're looking at the machines here, we can see that this machine had peaked here. We investigated and it rebooted. But the other 2 machines are kind of leaking CPU. And it's interesting for us to see if there are more machines in this data set that exhibit similar behavior. So we'll leverage some ML building blocks that are embedded in the Azure Data Explorer system. And in this case, we'll look for shapes. We'll look for jump shapes in the CPU consumption graphs. And you can see that the phenomena is actually broader than the other 2 machines that we've seen earlier. You can even see exactly where the phenomena started, and this is probably where we deployed the software that created this bug of leaking CPU across the workload. There are some more elements of machine learning already embedded, and this is, I'm talking here about unsupervised, but there's also the ability to run Python and more ML capabilities, and we'll expand on this later. But in this case, we want to ask a very simple question. Remember the 2.5 million errors that we've seen earlier? Let's take a look at the dataset and see how can we cluster those errors and see what are the main reasons for it happening. Now, this auto-clustering tries to identify what's common to many of the rows here. And you can see that 42% of the errors are generated by the SPI role, especially the SPI role machine number 4 that's generating a lot of errors. This actually pinpoints very easily what is the problem and how to go and fix it. Let's switch back to a little bit more about the Azure Data Explorer and the Kusto technologies. It's a data platform that uses a append-only mechanism to store streams of records. It's built for big data, high volume, high velocity, high variance. Our biggest table ingests over a petabyte of data per day into a single table. It supports a relational query model, so as you've seen, columns, row, filtering, sorting, etc., everything you can expect from a data platform or a database, including joins, calculated columns, etc., but also the ability to do full text search, time series analysis, and even running Python and R code natively, sending the code to data rather than the data to the code. It is fully managed on Azure, and it does not have a specific domain it is optimized for. It is actually applicable for many domains, and it is optimized for exactly that workload of analyzing activity records in very high volume, very high velocity. The last aspect is that it's optimized for interactivity, as we've seen. Today, this platform is actually ingesting more than 100 petabytes of data per day, evaluates more than 1.5 billion queries per day, and stores over 8 exabytes of data, which makes it one of the largest data platforms on Earth. In late November, we've actually completed the integration of Azure Data Explorer into Synapse Analytics and created the Azure Synapse Data Explorer offering, which complements the Azure Synapse Analytics family alongside the Spark and SQL engines in order to address the telemetry analytics workloads. A little bit about our journey. The Gusto technology was created by four engineers working on the Power BI team that went ahead and created a repository for logs in order to support moving services from on-premises operations to the cloud. It was very quickly adopted by every Microsoft service, including Office and Windows replacing Splunk, and the other services Microsoft followed. In the next phase, we replaced the underlying platforms for the monitoring, security, IoT, gaming analytics, and education analytics systems, and quite a lot more. And afterwards, we released it as a general purpose Azure service for activity data. It went generally available in 2019, and as I mentioned, 2021, late 2021, it's now part of Azure Synapse Analytics. So when is this technology applicable? The first thing one needs to decide if he's trying to find a solution for an online transaction processing problem or an analytical problem. There is a set of Azure services that are excellent choices for transaction processing, whether it's Cosmos DB for the non-SQL and the different SQL servers for the SQL loads. If it's an analytics workload, then until not so long ago, the answer was if it's curated post-ETL data, use Azure Synapse Analytics, and if it's raw data, schema on read, activity data, telemetry, use Azure Data Explorer to host the data. Recently, with Azure Data Explorer becoming part of Synapse, the answer is Synapse has all the capabilities to deal with the types of analytics that you need. When we're looking at cloud scale analytics and the common workload patterns that it serves, we're seeing the modern data warehousing pattern, which we'll drill into in a second, machine learning, and real-time analytics. Azure Data Explorer, the Gusto technology, deals best with real-time analytics. When we first launched Synapse, it covered the modern data warehouse. We added the ability to run machine learning on that, and now we are adding the ability to deal with real-time analytics in a scalable way. If we're looking at the modern data warehouse pattern, in the modern data warehouse pattern, the first thing is to design the model, understanding what are the entities and attributes of the things we want to surface, and then create an ETL that takes all the raw data that's relevant and creates a well-curated representation of the data so that it could be loaded into a SQL pool and then visualized with Power BI. In the real-time analytics pattern, data is streaming from a variety of sources into either real-time analytics with Azure Stream Analytics or to Azure Data Explorer for historical analysis and near real-time analysis of the data. After the data is made available for dashboarding, queries, ad hoc analytics, etc., it can also find its way to data warehousing or to the data lake, etc. When we're looking at the map of analytic needs, on the vertical axis, we see interactive workload on the top and batch long-running workloads in the bottom. On the left, we are looking at raw data analytics. How can we look at the raw data itself and understand meanings from it? And on the right hand, we are looking for well-curated, pre-processed data with referential integrity, transaction, what we can expect from a classic data warehouse. Data warehousing covers the right angle of this map. When we're doing advanced analytics, we're looking at the bottom line, running batch jobs on massive data in order to train models and sometimes score and test them. And when we're trying to run observational analytics with real-time access to data and the ability to apply machine learning on streaming data, there we find Cousteau for the interactive analytics and Spark for the heavy-duty model training. So now when we have the Data Explorer Cousteau integrated in Azure Synapse, which one should we use for a workload? The Data Explorer pools in Synapse are still in preview, but they do provide significant value with managed VNet and the integration. Let me show you how easy it is to create a new Data Explorer pool in Synapse Analytics. We're looking at the IoT Synapse demo workspace, and if we're looking at the Data Explorer pools, we can easily create a new Data Explorer pool, just like the home of the IoT data one. We can create a new one that inherits all the VNet settings, all the protection settings, and is already certified and registered in the subscription. So when Azure Data Explorer is available as part of Synapse, which one should we use? The Azure Data Explorer in Azure or the Data Explorer pools in Azure Synapse Analytics? Data Explorer pools in Synapse are still in preview, but they do provide significant value if you are already configured the managed VNet in Synapse Analytics, or if Synapse is already certified in a company. That means that you can very easily create a new Data Explorer pool with very little hassle. Let me show you how it looks like. Here we're looking at a Synapse Analytics workspace and you can see that we have like SQL pools for data warehousing, Spark pools for um, running ETLs, machine learning workloads, and data transformation jobs, and Data Explorer pools for IoT, time series, logs, etc. Very easily, you can create a new Data Explorer pools from here without the need for creating a new subscription or a new uh, or introducing a new service to your organization. Let's talk a little bit about some customer stories. Checkpoint Software has chosen Azure Data Explorer to be the underlying storage for their activity data that they reflect to their users of security devices, virtual devices, etc. Daimler Trucks North America and Mitsubishi Fuso has chosen Azure Data Explorer as a repository for their truck telemetry. Further, and actually created an application, Truck Connect, that is built on Azure Data Explorer in order to provide fleet managers with full control over where their vehicles are and what are the actions that they can do with them at every given point of time. They also connected the truck manufacturing factories. So now they can tell for each batch of parts which trucks did it go into, and if something needs to be recalled or serviced, they know where those trucks are and where is the nearest service center that those trucks can go to. Bosch is leveraging Azure Data Explorer for analyzing smart buildings and energy solutions, for preventing wrong way driving, for monitoring battery charging stations, and for road condition monitoring and solutions. Bureau Insights is using Azure Data Explorer in order to monitor and provide visibility for their customers on how their food processing machines are doing in their customers' tenants. They're also using it for data science and advanced analytics over this data. Tabula is a leading provider of content recommendation in the internet, and it's using Azure Data Explorer in order to monitor how content is delivered to users across the globe, providing visibility into their service quality and SLAs. Hilo, part of Hydro Quebec, built a virtual power plant that helps save energy by organizing when people are consuming electricity. All the analytics, all the operations are running on Azure Data Explorer to power the smart grid. AGL is monitoring huge amounts of batteries and solar panels across Australia in order to optimize how they operate, preventive maintenance, and more scenarios. So how do we get started with Azure Data Explorer, Synapse Data Explorer? Let me show you. If you open AzureDataExplorer.com, you can actually go and create a free cluster. So how do we start to learn this technology? Let me show you. If you open dataexplorer.azure.com and click on the Personal Data Explorer cluster, you can actually create a free cluster for your personal use on every identity that you have, whether it's a work or school identity or a Hotmail, Gmail, any kind of Microsoft account. A cluster will be created in a few seconds, and you'll be able to upload your diving log, your bank transactions, phone calls, whatever activity data that you'd like. We are also working on a Home Assistant connector that will allow you to monitor your smart home, open source system, and more. With that, you already have a cluster that you can actually use for the. So now we have a cluster in the database. We'll go and ingest some data. You can ingest like your phone call logs, your dive book logs, your bank transactions, etc. We'll actually go and ingest some test data. In this case, the storm events data. And now we can actually look at the schema and ingest the file. Within a few minutes, few seconds, we can actually go and query the test tables that we created. And we can get the data visualized in a few seconds. Please go ahead, try it out. It's a one per person. It comes with about like 100 gigabytes of storage, free of charge, and the plan renews every 1 year. And just go ahead and try it out with aka.ms ADX free, and do send us feedback if you have any. So what can we do next? Try out the personal free cluster and start with the Gusto technology and ADX. If you are a system integrator or consultant and you want to learn more, join us and take advantage of our partner program, please do. And please do reach out to us in any of our social and community channels, or to me personally, and I'll route. There is a lot of content here, and thank you all for spending the time with us today. Looking forward to seeing you using Azure Data Explorer, Synapse Data Explorer, and the Gusto technology in general. Thank you very much.